Just a little.
Not too bad.
Just a little.
All right, we're live. So we're group 4. I'm Keegan.
Tianna.
I'm Penny.
And we're going to go through the lesson 11 problems. I'm going to share my screen and then I'll start with question 1. Okay, so yeah, we're group 4, like I said, and it says number 1, this question concerns the molecules involved in translation. So it says, indicate the enzymes that covalently leak amino acids to the tRNA molecules, and that's the amino-acyl tRNA synthetases. The 4 proteins that consume GTP is the IF2, IF3, EF2, EFG. So that's the initiation factors and the elongation factors. C, one molecule that functions as a ribozyme is the 23S rRNA, or the peptidyltransferase. 2 proteins that recognize stop codons, you have the RF1 and the RF2. And the molecule that forms hydrogen bonds with the Shine-Delgarno is the 16S rRNA. And that's just all from the reading and the PowerPoint.
All right, for number 2, we did the fill in the blank. So the first amino acid in prokaryotic proteins is the N-formylmethionine, or the FMET. For B, an E. coli protein called F2 or EF2 delivers charged tRNAs to the A site of the ribosome during translation elongation. The initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site of the ribosome. The EFG is a translation factor that helps the ribosome move 1 codon in the 3' direction along the mRNA. And the IF3 is a translation factor that guides the mRNA to the 30S ribosome subunit. The AUG codon is a start codon, while the UAA, UAG, and UGA are examples of stop codons, all in the 5' to 3' direction. Degenerate is a term that indicates that more than 1 codon can specify the same amino acid, and the final amino acid is located in the C terminus of the polypeptide.
Awesome.
That's number 3. So this one, the question is, a series of mRNA codons are indicated below. Consider the wobble rules and provide all possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. So with the wobble rule, the first 2 will be complementary to the mRNA. So the first 2 for the A has to be AA for every single one. And then we get U, A, and C for the possible 3rd nucleotides. And then for B, we have the same thing where AGU, so the first 2 have to be UC, and then the 3rd nucleotide can be U, A, I, or G. And for C, same thing again, UAC, so the first 2 have to be AU, and the 3rd nucleotide can be G, A, or I.
All right, and for D, like she was explaining, so for all 4 of those that we found, they all start with UA, but the endings on the first one is I, and then U, A, or G. And then for E, it has to start out the CG, so it's complementary to the GC. And then we found that you have an I and you wouldn't have an A, there's an A already there.
Awesome. So I'll do number 4. So this one, we did a little math. So it says, suppose the E. coli contains protein X, which is 218 kilodaltons in weight. So it says the average amino acid is 125 daltons. How many amino acids are found in protein X? I converted the kilodaltons to daltons, then divided the daltons by 125, and I got 1,744 amino acids. So then you know that there are 3 nucleotides per amino acid. So when it asks what is the length, I went 1744 times 3 and got that there were 5,232 nucleotides. For the GTP molecules, how many are consumed to synthesize for their, each copy of the protein? While it's getting synthesized, we figured that each amino acid will use 2 GTP. So we went 1744 times 2, and then you just add the 1 GTP that's used at termination. So So that gives us 3,489 GTP. How many ATP molecules are consumed? Just one per amino acid, so 1,744. And the group of enzymes that consume ATP is the aminoacyl tRNA synthetases again.
Okay, so for 5, it says below is a list of proteins and nucleic acid sequences involved in translation. So for A, which of the above is involved in translation and initiation? And so these are all found in the reading and the PowerPoint. And so we found for initiation, there's IF2, IF3, 16S rRNA, the Shine-Dalgarno sequence, the start codon 5' AUG to 3', and then the tRNA FMET. For B, it says which of the above is involved in the translation elongation? So we found 16S rRNA, the EFTU or F2, and then the EFG, as well as the 23S rRNA. For C, which of the above is involved in translation termination? And we found RF1 and then the stop codon UGA. And D, which of the above is a component of the 70S ribosome? And so there's the two parts of the ribosome, the 16S rRNA and the 23S rRNA. And E, which of the above is found within the mRNA? And so we found the Shine-Dalgarno, the start codon, and the stop codon. And so let us know if you have any questions in the comments. And this is our presentation this week.
And I'll stop that. So perfect.